Really? No, that's not for sure. For real, I mean. Yeah. Where's the dot? So the problem was I need a piece of code to be moved to the front, but it ain't easy. Scale update. Yeah, just the other one. This is being called from approximation add. I don't think it's here. Okay, so update approximation does something and handle approximation does something. And I need to extract some code from handle approximation, I think, and plug it into the update approximation. But it wasn't very straightforward. I think the code is doing something like, well, it's the call to the find extreme. Now really I'm only interested in that call if the last region is still unknown. Or am I? There's another one, I think. There's another one here. I don't want to call it twice, so I could do it conditionally, but that would only be possible if I have the value of last region already at the moment I call this. Do I have that? That depends on where last region is changed. Maybe it's being passed to a function. Skill step, not really. Find extreme itself might change it. Yeah, definitely. This is what is setting it. So this call here calls find extreme, which then initializes the region. Well, that means that the first time we get here, this is true, and therefore we call the find extreme for the very first time, and then afterwards last region is no longer unknown. So I can test, definitely can test on if last region equals unknown at this point. And then conditionally call find extreme before we even enter this function. So do not do it here, but then I have the problem that inside this function I cannot test on this anymore. So I need a new boolean, then which tells me that I have to enter this this scope here. Let's start with removing this line here from that function, and then conditionally on that one. And I'm going to do here extra boolean first call. Now print it out. Keep the debug output up to date. Alpha. Yeah. This is .cxx. Let's update the header as well. Handle approximation. Oops. Which then means that I'm going to do this whole block. So this must become let me copy it. This becomes first call. And then I'm going to remove, yeah, I'm just interested in this call, I think. So just this. So if I do this call before entering this function, then nothing changed. Correct? Well, I only do that when first call is true, which is true when this is true. Then nothing changed. I just move this outside of this function. So let's delete this. And then we go to where handle approximation is called. Which is, thank God, only in one place. Gradient descent algorithm.cxx63. Yes, so normally if this is true, we would do this part inside this function, but now I'm doing it here, and then this function still behaves the same because I'm passing that value, even though this is now changed. And now the question is, how high can we move this upwards? Oh, there's a new W. I have to pass that as well. Okay, double new W. Hey, Arjan. Thanks. Let me see. Yeah, I think this is now correct. I still have to add this to the header now, and here, which I'll do that immediately. Although the new W is, yeah, undefined. If first call is not true, I do not really want to print it in that case. I guess you can do it to just print some nonsense then, but well. Or it could initialize the value in the caller. I'll set it to 0. It's just 1 clock cycle, maybe not even that. Anyway, so then here we must add that. And then could do CW debug only. It's a bit dangerous though. So code that does something and then goes away when you don't debug. Nah, it's, I don't know, silly, right? Just initialize it always. Well, actually, this is this is correct, of course, but why 0? I mean, the reason is that I don't want to print nonsense. I mean, if I would run this over Valgrind, then I would complain. So instead of using null, I'm usually using braces then. So brace initializer. To me, of course, this also just makes it 0. But to me, this means I need it to be initialized, but I don't care what the value is. So it does not have any special meaning. Well, if you said 0, then you might have the feeling that maybe it has to be 0. 0 is important. Maybe I'm going to add something to it. Well, this is more... This tells me that it is irrelevant, that it is what the value is, actually. Okay, that aside. Now I think that we can move this upwards because the last region is simply, since the constructor unknown, and it's only going to be initialized by this call because it's passed by as a reference. Therefore, this is independent of any other code. And these things the same, right? I mean, one of them is this is pure output. This is oh god. Oh, this is pure input. This is input and output. But yeah, and next stream is exactly known already. It must be unknown as well. So that won't change. And this is input. So now the question is then, when is age restriction being initialized? Apparently before we get here. I have the feeling that happens inside this function as well. So this is also still having the same value since the constructor. Yeah, must be. In other words, this might as well be put up here, for example. There is a little difference though, because there is a return true here. So it might be that now I'm setting that value and I'm setting that value and then I'm returning. So then if this same function is entered again, then this is no longer true. No, we don't do this. Well, before that would not have been the case. So I think that in order to move it above this part, I should restore these two values, which are changed, might be changed, to the values that we were before. One of them we know. I might already do that here before calling handle single sample, even though I don't think that uses those things. There was a next extreme. Nope. And the other one is the last region. No. So before or after, but I suppose that maybe it's. Yeah, well, there's a. I can restore them here, but hey, this didn't change, did it? Well, not yet anyway. So I could do here if first call and this is not equal to 1. However, I want to move this even higher. And I think that the number of relevant samples is being changed by this call. While I would like to move it above that. Ish. It's not possible, but... No, okay, but now I moved it here. Let's first do the obvious thing. So this must be unequal 1, otherwise, well, we return, and I don't want to do this. I'm using a approximation pointer here instead of approximation. I will do that here as well. Where's the other one here? So approximation pointer. Then we are no longer. Oh, wait a minute. Underscore. That I'm no longer using that. Am I here? No. So this can now be moved below that point as well. And I don't think I can move this block above this call, however. Because find extreme uses the cubic. Find extreme uses the cubic, yeah. And number of relevant samples. Both are changed by that call. So I can't go calling this before the update has happened. What else is this using? Cubic, number of relevant samples. I don't think anything else, right? I don't think. Well, it's using parabola here, which is absolutely horrible. I have to get rid of that completely. It's using restriction, which I'm passing. Not sure what that is initialized. Okay, so update approximation. Either calls this or that. I think I want to, or have to, move that code block into the call to add. So it would be nice if I don't have to call it in this else, so in this case. But is that true? Thus, The question is, if this is not true, then isn't it the case that we already have set a loss region? I think that is correct. Because if this is not true, then it is pointing to the approximation stored in an extreme, which means that we found an extreme. We can only find an extreme by already having called find extreme, basically. So yeah, this is not before that we called the first find extreme for the first time. I mean, if you get here, so we think it never has to be called in this case. I guess we can do the following. I can move it to this point here. This is just debug code. It's just triggering an event so that stuff is being drawn. Debug output, another event for drawing stuff. So that doesn't do anything. So currently we are calling the code block after this function returns. And then if you say, well, but we are only going to call it if this is true, then we might as well do it here. Because that's kind of like after it returns. After that we basically return. A reset might happen though. I commented it out now, but yeah, that's like the comment says. So if this happens, then we call reset history, after which this is true again. So then we still need to do this code block, which then is just repeated. Calling add. Because this is commented out, I'm not passing next extreme type. But it should be the same thing, so pass that here as well. Nope, does not fit. So likely then whatever happens here should be done here as well. I think that the disconnected is a return value that is only happening from update scale and not from add. But that totally matters here. Let's see where the disconnected is set. So this update scale. Would quit all. If return, suppose that's the one. That happens when that is the yet to be written function return value. Okay, now I'm confused. Oh, this is being... No, wait a minute. This is scale update. Okay, so scale update does return it if the new sample vertically deviates more than 10% from the previous approximation. If the scale grows, scale update. Okay, how do I get here? So update scale. Calls that scale update. But that doesn't mean that this add doesn't call it as well, does it? So the the approximation add also calls it here, scale update. Can dit return disconnect? Queue initialized. I don't know why not. Yep, well, that's what I mean. It's not trivial at all. Well, this was commented out anyway. I don't know. Let's just ignore it for now. It's gonna bite somewhere in the future, but well. I'm still looking for, I think what I want here is a repeat of this block, so maybe I can just combine it into one thing and then but just reset history. What does that do? That calls reset on approximation as well. Which changes everything. The number of relevant samples is set to 0, and then the scale is also reset. Seems to me that then we just have a single sample. It's going to be the first sample, which in turn means that history approximation with the first sample. Not a replacement. Number of relevant samples becomes 1. Number of relevant samples equals 1. So we just have the straight line. Number of relevant samples is not 2. There we don't call scale update. So after this reset, this add will not call scale update. I don't know yet. Let me type this discovery here. Okay, now well, that's enough. I'm gonna ignore this commented out stuff for now, and just put whatever here. Put here whatever I want. So now I could put here. I'm still not sure. Well, I think I explained it a minute ago. Would have got it again. Oh, yeah, right. So I can add an assert here to make sure that even if it would never be called. So let's first move this code here. Update approximation. Why am I not? It's kind of annoying. So this code block is now called immediately after update approximation. And for the newcomers, this code block came from somewhere inside this function. I slowly moved it outside this function and then above here, and now I'm going to disappear inside the update approximation. So this part is now called after update approximation, but to delete it. Oh, wait a minute, I can't do that just like that. The new W is passed here. And first call as well, so I still need that in this scope. I think this can be moved above it. The last region. Because update approximation doesn't change last region. And then I can pass first call and a new W. Well, you can pass references to them, to this function. And then if this function changes them, then it's the same as if they were changed in this place. That one, these are just members of the current object. You're still staying inside the current object, just calling another member function. Yep, that shit looks good. Though new W is not used, so I might as well return it, I guess. But that's a bit dirty, maybe. Wait a minute, I don't need, yeah, I have to, wait a minute. I don't have to pass first call. Because it's a constant, I think. It's not changed. That wasn't changed here. So we can just do this test again inside the update approximation, I think. It's passed both here and there. Yeah, right. The call to find extreme changes last region. That's why I needed the boolean here. But that's here. Yeah, you can't do it afterwards. Okay, so I need it here, and I must, since this is now going to be moved inside approximation, first call must be initialized before entering here. Otherwise, yeah, well, this is going to be changed now by that call. But let's make it a const just to make it clear that that is not being changed. This I might just change into, you know, assignment. And then first call does not need to be passed to this function, really. I can just do the same test again inside of it. So loss region will be changed by the call to update approximation, which might call find extreme. And this one, because I'm going to move that inside of it. So now we can delete this. And then before there was no new empty line. I don't know why, but I want to keep it that way. And now I'm going to put that there. And then I didn't pass first call, but we do need it. And yeah, let's just copy it from here, I guess, again. And then the point of this assert was to make sure that there is no need for calling this. And actually it should be upon return from update skill. I suppose it doesn't matter, but let's do it here anyway. So in this case, this is like the end of this function. So instead of calling it after this function returns, we call it inside a function before we return, which is then here or here. But I'm not doing that, and I want to make sure with an assert that that is correct, which means that I want to test that this is not true. If this fails, then apparently we even have to call find extreme in this case. And then here are some question marks actually, because I don't know. Okay, we finally moved it again. Now it's being called here, but also that is not good enough. I have to move it inside add. So again, now it's called when add returns, so I could call it inside add, just immediately before that returns. However, add might be called elsewhere as well, and it's not. It's this instance needs to do this at the end when it returns, but maybe the other ones don't. Let me first make sure how many calls to add are there. If this is the only one, then it would be okay. If this is the only one, then the easiest thing to do is just rename the add. So we have approximation pointer, which is an approximation, which has an add, and I'm going to add a 2 there and a 2 here, and then see if something goes wrong. I think I got I got rid of my dots, so it should be compiled now. I did not get rid of dots. Two, this one is still, that's the definition. It should be renamed as well, of course. Damn it. So there is another one. And another one. But it's in the test. Let's just rename them both. Yeah, update approximation is going to have to return a double now. This is new W. Highly dubious. Okay, so we have a double, new W, which I initialize with something I don't care, just because sometimes it's not initialized, namely in this case. And then in the end, then I just return that. Turn new W. Right, so the add 2 happens. Yeah, in one place, but also in this test. But I don't think I have to take tests into account. So you're going to do this always, then. Hopefully that won't blow up this test, but well, then the test has to be changed, not the rest of the code. Nevertheless, let's rename add 2 back to just add. Okay, now where was I? Oh, I have a thing with dots apparently. No, it's not the way to find this back. How about, I know I commented it out. That's a lot better already, but still not nothing. Okay, get diff then. Yeah, there's a lot of spaces between it. I want my dots back. And I think, I don't know. Add. Nope. Algorithm, of course. Oh yeah, right. So this is the only place where add is being called. So therefore, I can just do this stuff at the end of add. Provided I have all these variables again, which I need. First call and next extreme type. Oh, that's ugly. Calling find extreme inside this member function is really ugly because I'm passing 3 member function of the current object. I'm definitely not going to pass. I mean that would be really bad coding. Let's draw a line here, right? But then how to do it? Then I suppose I could move it inside this function, because we should get near to the end, right? So I could move it here, and then the thing is, what I really want is that it is done before this call. But it must be done after this call. So in between. I need it here. But I don't want to do it inside this function. So I'll have to split this function up into 2 functions, and then we can call the caller can still call it. It's just horror. That's what it is. Why would I split up add in 2 functions? Well, because update scale is not the same as adding something. Hell, even initializing the approximation isn't the same. Is it? Actually, it is. I think that's what this whole function is doing. It adds a single sample. Yeah, it adds a single sample, and then if we have 2 samples, no, if 1 sample we do this. If we have two samples, we do more interesting stuff. Maybe we can do like that or something. Okay, this is actually making the approximation then. So I update the stored samples, then we update the approximation itself. Then I need to call find extreme, and then I can call scale update. Where slash how to split this function. Okay, and this returns scale update, so that's kind of nonsense then. I need a new name. What should I call this? Last part. You would say update scale, but I already have an update scale. How the hell did that happen? So this function should only be called when on an approximation that is part of a local extreme. So I'm going to rename this one to update local extreme scale. This then is no longer a result. It must be void. So this add is going to be void. It's add of the approximation. So this one is void. And I am going to have another one, which is update scale, which I don't know what to pass. With arguments. And then This one must be split into two functions, so this one ends here. And we make another one, which is scale update, approximation update scale. Oops. Like that. Yeah, so this is new, and therefore I split this function in two. And then what arguments do we need? Current is replacement is needed, so I'll have to pass that. And that's the same argument that was passed to this one. Number of relevant samples, that's just a member function, a member variable for the approximation, so we still have that. Result, scale, also member. The finish is, well, this one does not have a return anymore, so no continued here. No arrow here. Yeah, I can just copy it, I guess. Update scale. No, next extreme is necessary, and this is necessary, right? Just two more things. So what is next extreme? Looks like something that was passed as well, and hopefully not changed. Nope. So that is then this thing. And he already had two samples. Where does that come from? Oh, that's set here. I don't think that's all either. I don't think that that one is changed, but it's already had two samples. Yeah, so this is changed. That's annoying. I have to return that from this function. Can make it a member function to reduce the annoyance slightly. Yeah, I think I'm going to do that. Let's make this a member function, a member variable, I mean. So I don't have to pass it all over the place. That then still will exist here. There. So update scale now has this is parameters. which is the same as these two. So I still need it in the update skill now, the new update skill. And then here we are going to call update skill with the last two. So now I did split this function up into two functions, namely the first part and the new part. And then we can do this in between there. And nobody knows if it will work. Anyhow, so now we should have a call to find extreme before update skill is being called. And that means that we have our next extreme type set. Or do we? Oh yeah, wait a minute. Yeah, and if it is not set, then okay, let's enter this function now. Wait a minute. Do this update skill here. He's now calling skill update if the number of relevant samples equals 2. That was significant too, I forgot why, but hey. Okay, so skill update, it's now called. And then even though critical point type is none and next extreme type is unknown, we still have called find extreme already, which actually means that if next extreme is still unknown, that yeah, type should be critical point type inflection point. Which warrants a comment, I guess, but I only remember that that was the case from something I saw yesterday. I don't know why anymore. So yeah, we would have to look at so something like next extreme is set in find extreme. Let's go by find extreme, and find extreme sets then extreme type to unknown if and only if d is less than 0, del less than or equal 0. I think, I hope. Well, not true, because it's also being said there and there and there. Oh no, that's just 2 cases, but it's enough, isn't it? Oh, there are 3 cases, of course. 4 cases. A billion times. So yeah, figure that out. So in this case, at least, we don't have a minimum and maximum, therefore we must use inflection point. But what about the other cases? When the hell do I get here, for example? The cubic looks like a parabola with an extreme type different from what is requested. And that is important because, I mean, the requested thing. I think, wait a minute, requested means that's this extreme type, I think. Yeah, this whole thing. It's set to unknown if it is not unknown already, which means that I don't know. It just has to work, you know. There is some kind of logic in the code that if it works, then this should be the case, I think. And I don't know how to, what kind of assert I could add for it. I'll just have to wait until, if it goes wrong, I'll just have to wait till some test fails or something. Yeah, to finish these comments. See what also if restriction is set, it could be this basically means that there is no solution, which is not the same as an inflection point, of course. No fucking clue, man. I could add an assert, I guess, here to check if the cubic does not have a minimum or maximum, then at least that will very quickly assert to have access to the cubic here. I have access to some cubic, but not sure it is even set yet. Yep, so I'll have to add that one, which is a boolean, and I have to add it to approximation. Oh shit. So what happens if I put a return here? That is simply after a scale reset, and then I leave this function. Yeah, which just continues, I guess, here. Update scale. So that would be good enough if you just do this, because that's what they want, right? To return first sample, yeah. Redo. So I just want this to be false, and that definitely false, because the number of relevant samples should be not 2 after a scale reset. It's set to 1 actually, it's because of this one. Right. So this one also has to be split into calls then. Approximation add, and then AR approximation update scale. Here as well. What? So we get a new approximation and I add something, so that must be the first sample. And And now we add again something, and if you're still stuck on first sample, then forget it. Otherwise, we have 2 samples, and then we can continue with this. And I'm calling find extreme, which is kind of weird because that should now already have been done, right? Or, well, actually it should have been done in between add and update scale. I'm not taking into account that it returns first sample, I think. Something is wrong. But got the feeling I introduced a lot of errors. Still the annoying implement. Okay, this thing generates this cubic, which has a minimum there and a maximum there. Sample left is it generates 2 samples. Here, digit sample left and right. It generates this is all randomly generated, so no restriction, extreme type, maximum. And now we're going to find, I think, the maximum, I guess, so at this point. Yeah, this is a test for find extreme, I suppose. So adding the 2 points to the approximation, that's these 2 points. So we just see them repeated. And the other one. This is correctly the first sample. And well, this one crashes before it prints it. Okay. During the second add, we have a problem fit and a cubic fit. Well, the problem is going to be removed, so I don't care. The cubic fit matches exactly the cubic that it is. That's good. Then we call update scale, which calls scale update, which then says that is not implemented. And that should be because the thing that we're looking for falls in between, I think, the 2 points that were added. And I don't think that's the case, right? That's not the case. We have the 2 samples are -0.5 and -2.7. My maximum is not in between. Let's have a breakpoint here. And see why we get there. Oh wait. Break. Skill update. Run. Yes. Okay. So. No, so more than 2 relevant samples should be false because we just have 2 samples. And obviously this is not valid. Neither of them is valid. Okay, so now we're going to add them. And there's an initialization, this should be equal to none. The next extreme type, I think it was set to maximum, right? But it's just as a test. Because apparently we're looking for a maximum, I'm setting the type also to, which was none. I'm setting it to maximum. So now type is also maximum. And then assert false. Well, that's shocking. Oh, I was confused with another function. Yeah, there's no in between here. I just always search as soon as you call it. Yeah, so this function is not implemented, do some stuff, but in the end we just run into code that is commented out and then in all cases assert. So that makes completely sense then. And that was which test? Generate cubic test, okay. Let's try running the gradient descent test soon. That should get a little further. That's not bad. So the last test is jump to minimum. Okay, makes sense, makes sense. I thought I was always printing my minimum and maximum of a cubic, but here I'm managing to print a cubic without a minimum and maximum. Yeah, again, I don't think there's anything to test yet. I just have to continue with my function. If type is unknown, then set it to inflection point or minimum or maximum. So now it's known. If it was known, then it should correspond. Which means the type is now set. It was super important for the what is coming next. Get the x coordinate, the w value of the vertex of the parabola, but now we must get the critical point. And that depends on type. Can I not just call that like get the x coordinate, w value of the critical point of the new cubic. Let's rename it to CP instead of V. CP for critical point. New Vx becomes new VTTT. CPX. New parabola. I call that approximation. Yeah, maybe I should call it new cubic anyway, because I'm using all characteristics of the cubic. We could call it cubic approximation, but well. Kind of silly to already replace this with new cubic while still in this old code assigning it to a parabola, but well, that is the data that I have, so I think I'm going to do that. So we replace a new parabola with a new cubic, which is now the thing that we have. Is the argument. And then we need to get from the new cubic the critical point. I think, yeah, it even highlights. Critical point W can be called on scale. Is this a scale? No, it's not. New cubic. I'm getting a cubic polynomial here. I don't think we don't. I'm not having a scale yet, right? This is the initialization of that. Okay, let's see what the cubic has. I think it only has get extremes. This function. Derivative, second derivative. Yeah, that's it. You have to do. You have to do with get extremes. Is that not kind of where to do that here though. I mean, were those not already calculated? No, I suppose not. Forgot what the other one was. Top. Why is this not? Oh, it is. Well, yeah. Okay, what am I looking for? I'm looking for where the cubic is initialized. Something with cubic initialize. Initialize, like this function, which does not calculate any. Yep. Okay, so we don't have the extremes yet. Well, then maybe I should just call it here. Okay, extremes. Control top. Now note that even if this returns 0, it does return the inflection point. So if it returns 0, we do have something in 0. And I can also treat this case where it returns 1 as an inflection point, to be honest. So either it returns 2 and we have a minimum and a maximum, or it returns the inflection point in index 0 and does not return 2. So I'm going to assign the inflection point value. And then if number of extremes equals 2 and we want a maximum, then that was wrong and we should have assigned the first index. Which then of course means that this should put minimum at index 0. Again, that's I think it does by default. get extremes. Oh, it must be called with the thing, but then leftmost first is true. Oh, wait a minute. So I have to pass false. Then it puts a minimum in index 0. Okay. Oh, forget X. I just no. Wait a minute. Yeah. Well, I don't know why I'm calling it X here. Get the W coordinate. And then here I'm calling it X as well. Screw that. Right. Slow. Next one. Pick the sample that is horizontally the furthest away from the new vertex. So that becomes, can I do this? Pick the sample that is horizontally the furthest away from the new critical point. Sample, edge sample is I need, however, two values. One for the left side and one for the right side now. So probably should make this an array. Pick the samples that are horizontally the furthest away from the new critical point, respectively to the left and the right. And then I make an array with the size of 2, which is going to contain those two edge samples. And then I'll make a loop. And I'll just call it scale, I guess, left side less than or equal scale right plus side. It's a difficult way to type. Side is 0 or 1. This is 0 and this is 1. And then I'm going to assign both of them. So now edge sample side becomes And then I don't want to have the absolute value anymore. I just want to have values that are on the right side. Okay, this is difficult. Let's see if furthest away now means furthest away to the right side. So let's say if side is right. Okay, let's do this like this. If side equals scale left, do something else, it's right. And then what we want is the symbol that is the furthest to the right, period. Which means that I have to remove the absolute value. Do I still have a previous sample index? Can't remember that. Oh, that was set. Okay. Yeah, because if this is very large, that means that it is on the right. Then this becomes large. And if it is larger than the other one, then we pick this one, another one, otherwise you pick that one. So this is then the symbol that is the furthest on the right. But a negative value should not be accepted, because then it's actually on the left. And then I guess I should set it to 0. Okay, let's start with setting it to 0. So the standard maximum of 0.0 and this value. Oh, no. And then in the left, for the left case, I should invert this. So subtract this from that instead of the other way around. I don't see an easy way to short circuit that. So I think I'm gonna remove the loop. Just do it for both values separately. In this case, the side is just left, and here I have it right to right. No loop required. Oh, wait a minute, I'm making a big mistake, as usual. Yeah, that doesn't work, of course. Man, what a mess. Should have put this here. But okay, let me see. Left must be less than 0. This should work, right? This picks the leftmost sample, which means the smallest sample, smallest W value. If this is smaller than the other one, then we pick this one. And otherwise, this must be smaller, so then we pick that one. If they're equal, I don't care. And yeah, edge samples seems to be, it's a sample pointer. Yeah, okay. So we just store the pointer to that sample, which is the smallest value. Unless both of them are on the right of the new critical point value. Then we just fill in 0. I think this is correct. Yeah, whatever. Right, these two things are pointers, so this should be a null pointer. Yeah, null pointer. Which I guess brings me into a problem here, because now I have a null pointer. Which I shouldn't dereference. Do I have a print pointer somewhere? Well, I had it in my Vulkan engine, but don't know if I moved it to utils. Apparently not. This stupid operator wants the same type on both sides. No, I did enough. I want to see something. Maybe I do want to make it const, actually. Just and I forgot to dereference them. Well, I guess that makes sense. We're looking for a minimum, therefore we find the minimum, which is 2.5, use it as a critical point. These are the two samples that were passed, it says. Well, I believe that. So, I'm calling it operator, sorry, we call this operator with value 13, which is added to the history and added to the approximation, and then this one point here, and then we call it with 10.375, just added to the history and added to the approximation, which then now is the second sample, so we can make a cubic. But the whole thing looks like a problem, pretty damn close. This is almost 0. Nevertheless, returning minimum because that extreme is closest to the center of the two given samples. Well, I was asking for a minimum. So why return it because it's the closest? Just return minimum. Oh, it says unknown none. That's kind of weird. That is weird. Why is this unknown? Why is it not minimum? Yeah, okay, that was not, sorry, that was not requested. Nope, it's, this is the first time that we see minimum. So after this we're looking for a minimum because, well, that's where we want to go. And the reason is that it is the closest to the center of the two given samples. Yep, so from the samples at 13 and 10 something, we want to go to the left and to the minimum, which is at 2.5. Update scale. Yep, and this is the edge sample, and it's on the right of 2.5, so it's the right edge sample, because it's the furthest to the right. Now, I don't know, looks good, I guess. I think I'm gonna stop and eat at a normal time. It's at 6 o'clock here, 6 p.m. So I'll be back later.